Hi guys. Most of the people solve this in O of big O of n log n, but the interviewer wants O of n. Here is the trick behind the longest consecutive sequence in this blind 75. In the given problem, we need to find the longest consecutive sequence in the unsorted array. For example, if the array is given is 100, 4, 200, 1, 3, 2, the answer will be a 4 because 1, 2, 3, 4 is a consecutive, the series of numbers. So if you've thought of about a brute force approach, we can go with the sequence. For example, 1, a number plus 1, 2, number plus 1, 3, 4, like that you can go until the loop breaks. What is the problem here? There are a lot of repetitive work, right? So the time complexity will increase. It will be n square, and the space complexity will remain O of n. And yeah, for it is fine for smaller inputs, but if you give the larger inputs, that this approach will be a slower, since if you have array of n, it will give n square of time, right? If you have size of 100, it will take 100 square time. So what will the next approach you might think is sorting, right? The better approach will be, the slightly better approach will be sorting. After you sorting this, it will become 1, 2, 3, 4, 100, 200, right? So you might think using this approach, we can reduce the time complexity by n log n times. But it is not a still not a optimal approach. We can do it better, it less than log n time. How can we achieve that? Using a concept called hasset. In this we are using Java. So in this Java, the hasset basically it's come from the set interface, the library in the Java, where it stores the unique element. The uniqueness of this hasset is it's only stores the unique element, and we can remove the duplicates. We can avoid the duplicates over here. And in this hasset is the main advantage is that performance. It will the removal, adding, or to check whether the element exists, it will perform in O of n time, O of 1, and this has many methods like add, contains, remove, and clear, size. Using this, we can implement over here. Basically, first what we are doing, we are put all the numbers in the hasset, and we are the lookup become O of n, right? The time complexity will for this is O of n, O of 1, sorry. So the lookup become O of 1 for putting all the elements in the hasset. Next, we are iterating on the hasset. Now, basically, in this approach, we are starting the sequence where it is. For example, how we are determining where the sequence starts by using this one, number minus 1, num minus 1. If, for example, if you have 1, 2, 3, 4, if you are at the 2, you will find that the 2 minus 1 will be 1, right? That is the starting point. So we are at the starting point, right? 1, 2, 3, 4. We are starting from the beginning in this array. So if that number does not, for example, 100, if you take this 100, the number minus 1 means 100 minus 1 is 99. 99 does not exist in this array, right? So this will be a not starting point. So we can skip this number. Like this, we are iterating and we are finding the right place to start the sequence. Here it will be a 2. From the 2 we will get, for example, 2. If you are at the 2, we will get 2 minus 1 is 1. Yeah. If 1 can in the set 1 is exists, yes, it is exists. It exists. Yeah. Set if the previous number does not contains, we are skipping that number, right? And if it exists, we are continuing to find the longest sequence. For example, if we are at 1, if we are not finding it, it is 0 is not exist, so 3 minus 1 2 exists, but the sequence between 3 minus 1 2 2 3 4 3, the length will become 3. And next, we when it is at the 2, 2 minus 1 is 1, 1 exists in this set. So from here it will start iterating, and 1 2 3 4, and the maximum length will update to 4. In the end, we are having the longest length in the of the sequence, so finally we are returning that. This is the basic what you call best approach we are taking to solve this problem. So the time complexity will reduce to big of n, and the space will take O of n. Since they have mentioned that you must write an algorithm that runs on O of n time, so to solve this, we have to consume some of the space, so it is taking O of n, a space complexity. And in the interviewer might ask that how you are avoiding the duplicate. The one answer you might remember that in the hash set, when we are putting, we are skipping the duplicates, right? We have seen that there is no it does not allow the duplicate values. One is that, and second is that we are expanding from the sequence starts, not from every number, right? That's the pattern recognition that the interviewer wants or expect us when we are solving this problem. Yeah, thank you.